And on this note, we are going to transition to the second part of the event, where we were going to focus on the large corporations and companies that deliver some of the products that we grew to love and use on a daily basis. They're going to share with us their secrets of how they deliver such amazing experiences. And we're going to start with Roman, who's going to talk about the fully automated release for FB Lite at Facebook.
My name is Roman Kushnarenko. I'm software engineer at Facebook as part of release engineering team. And today I'm going to talk about fully automated release for Facebook Lite. Yeah. And before we start, I want to say huge thanks to Taras for organizing Scaling Continuous Delivery event. It's really awesome, and I'm very happy to present here today. So really thanks about that. On our agenda, we will cover a bit about Facebook Lite. Then we will spend most of our time on how we basically fully automated release for Facebook Lite and the backend side, and we will finish with few takeaways. So Facebook Lite. Facebook Lite provides optimized Facebook experience for people in the emerging markets, the majority of whom are using low-end spec devices and located in poor connectivity area. So on the left, you can see actual screenshots from the Facebook app, Facebook Lite app. From the high-level architecture, we can see the Lite client. They're very thin, and we can think of them browser-like. The APK size is less than 2 megabytes, and the product logic is offloaded to the Lite service. Both client and service communicate through Lite protocol, and the service holds a state for each session. The Lite service also communicates with other Facebook backend services such as image service and others. We have hundreds of millions of users monthly using Lite products, and we have a big fleet of Lite services. So our talk today will be of how we fully automated release of Lite stateful services. So yeah, let's start. So before we start and before we go deep diving, we want to mention the personas we actually care about. So first of all, there is a users, everyone who consumes our apps and services, and they want a great experience. They want a zero regression, no bugs. Another persona are developers, everyone who brings a new update experience to our users, and they want a quick feedback loop. They don't want to be notified on false positive signals as part of the release, and they want a high release cadence. Another one are release operators, and basically the people who manage the current release and make sure it goes on time with high quality. And they also don't want to have any noise from the release process, any noisy signals. And they want to reduce a manual work as part of the release process. And CI/CD team. So basically the people who build the infra to enable releases of apps and services. And our goal is to run high quality releases regularly, automatically, and safely, having delightful, simple, and high signal release experience. Those are the main building blocks used as part of the Lite server releases. So let's go quickly through each of those, and we will deep dive later into the interesting parts. The branch cut. Now, when a new release is about to start, we create a new dedicated branch for that. The build is compiling and creating a package for shipment. The tests are unit tests, integration tests, end-to-end tests, and all kinds of tests. Canary and analysis. This is the way to detect regressions before we ship to the whole fleet. And the stabilization includes two parts, the attribution and remediation. So for the attribution, we use Multisect. We'll talk about this later. This is how we find the blamed commits. Once we found those, we use a revert and pick techniques to stabilize the branch. Shipping 100% is deploying a package to the whole fleet. Orchestration is the thing that is responsible for the managing whole release cycle. And the tooling integrations is to keep other tools aware of the release process. And we also have two terms. So the first term is happy path. Happy path means we have no regressions, we can ship. So let's look on the diagram on the right. We have a main branch where all commits are landed. At some point of time, we decide to release. So we create a new release branch. This is a branch cut. We build, we test, we run a canary, we analyze, and we found no regressions. Great. This means we can ship to the whole fleet. We have another term, which is a non-happy path. The non-happy path means we found regressions, and now we need to stabilize. And again, let's look on the diagram on the right. We have a main branch. Again, we created a branch cut. We did a branch cut. We have now a branch for version 1. We did a build, we did a test, we canary and analyzed, but we found regressions. Now we need to attribute. So we do a blame. We find the commit which introduced the issues. And then we revert and pick to the main branch, and we revert into the main branch and pick to the release branch, to the version number 1. Then we run again, we run a build, we run a test, we carry an analysis to verify that the issue is no longer there. Once there is no regressions, we can ship to 100%. And the important is that, and this is important, when we say fully automated release, it actually means that we have automated the non-happy path. So now we are going to deep dive into actually how we implemented the detection, the attribution, remediation, and shipping parts, and see how it looks for Lite. The detection part. The detection is responsible for finding regressions, for detecting regressions, and what types of regressions we might have in compilation, availability, performance, functionality, product business metrics, and other, you name. And we look for some parts that are really important for the detection regression, for how we detect regression. So first of all, we want to detect them early as possible. So if it's possible to detect in IDE, it's perfect. If not, then as part of CI process, if not, as part of the tests. So as early as possible to detect those, it's better for developers. They know about those issues earlier. Reduce exposure. So this is also connects to the detecting earlier. If we couldn't detect it, so we will start exposing the release candidate to some number of users. It can be part of the gradual or part of the canary, but eventually this is how we can get enough confidence about the regression. So important part here is that we should expose to a minimum number of users and to get maximum confidence about detected regressions. So we should be mindful about the user experience, but we also should detect regressions. So this is a trade-off. Zero noise. For the zero noise, we should make sure that we are not creating any false positives signals. So if we say something is a regression, but it's not, it affects the developer experience, and it's basically difficult to automate the release process and catch them all. So this is obvious. We should detect all regressions before we ship to prod, and we should catch them all. What are the techniques to detect? This can be part of the build, test, dogfooding, canary, gradual route, and analysis. We're going to deep dive into the canary analysis. Those are interesting parts, and we all use of them as part of the Lite release process. But the canary analysis, we want to deep dive a bit more. So the canary and running the analysis. So how we do it? So first of all, we prepare two packages. One is a test, the another is control. What is test? The test is the release candidate, the package that we want to ship to production. And the control, this is our production package. It's already running on a servers. Then we choose same number of servers for deploying a test and for redeploying the control. So we redeploy the control. Someone will ask, okay, but why we deploy again the prod version? And the reason is because there might be a startup issues that if you will compare the test versus existing prod, we will not detect them because they're already running. So we deploy both versions at the same time, and we use load balancers to bump more sessions into those servers. And the reason we are doing just to make sure that the servers can hold the peak times, and it eventually helps us to reduce number of services we need to use for the canary. And we wait. So after waiting, we will see this graph, number of sessions for the canary time, and we will get the table on the right. So this is example table that shows number of shows the errors we see, and number of crashes happens for test group and for control group. Okay, so let's see from this example. For example, the crash A, we see pretty similar number of hits, so this is not a regression. And the error B, we will see that there is actually a new issue that started happening within test. So one of those changes as part of the release candidate introduced the new issue, and we should find it later on. So B is a regression. The C is also regression because we can see that it's existing issue in production, but now it started spiking and it increased, it's doubled. You can see that D is also very similar to C. It's the same as C, but it will not be, it won't be a regression. And the reason is because we're running a statistical analysis, and we not only look on the summary of the hits, we also look how the issue is behaving on each of the servers. And in some cases, one of the servers, for example, can disbehave, and other servers are fine. So there should be some analysis running, and eventually D won't be mapped as a regression. So in this case, after running the canary analysis, after 2 hours, we know what are the regressions we have. In this case, it's a B and C. So, okay, so having the detected regressions as we saw before, and those regressions might be a spiking crash or a dropping metric, we should be able to find the commits which introduce those issues. And you can imagine there is many changes as part of a release candidate, and it's an interesting problem. It's important that attribution will not provide false positive results, as it will lead to wrong reverts later on, and we'll talk about this. And reverting wrong commit is a bad developer experience, obvious. How we can detect those issues and find the blame, is by running bisect or multisect or some machine learning techniques, and there is others. So as part of the Lite, we are using multisect. So what is multisect and how it works? So first of all, we start with the range of commits, and we don't know which one to blame. And this is the question we are asking. What we are doing? We are slicing this range of commits, in this example, to 4 slices. And for each slice, we create a build, test it, and we have a package. So we have packages A, B, C, and D in this example. So once we have them, we ship them in parallel to number of Lite servers. And we wait. So after some time, for a given crash, for example, if it's a crash, we are going to look in the table that contains all those crashes and see that for package A, we don't have any crash hits. For package B, the same. And we start seeing that for package C and D, we see those crashes happening for the first time. And what it means? It actually means that we have found the regressing slice. So in this example, it will be slice C. And slice C contains multiple commits, right? We still don't know which of them introduced the issue. So what we are doing next, we are doing the same. So we repeat this process. So we build, test, and create those packages. In this example, it's a D, E, and F, and each package for each commit, and deploy them. So, and again, we are waiting, and after some time, we can see that for package D and E, we have no crashes, and for package F, we see the crashes happening for the first time. And what it means that we found the blame commit. So this is the example, and this is how the multisect is executed for Lite servers. Cool. So what's next? So having the bad commit, we should apply the remediation steps. Remediation. Okay, so having the blame commit, as we found before, the next step is to bring the fixed code into the branch. And what we are doing, we are reverting the blame commit within the main branch, and then we are picking the reverted commit into the branch. So yeah, we are reverting and picking. So someone might ask, why reverting? And the reason why we're always taking this approach is because of the following reasons. So it's always the safest path, going back to the working code. Also, waiting for the fix will block hundreds of developers from shipping. So you can imagine many developers know that there is a new version that should go to production. but this version is stuck on waiting for the fix. And it's also the fix forward actually doesn't guarantee a good results, and it's may introduce new regressions, and then we're in a kind of infinite loop, and it creates a lot of pressure on a developer who try to fix it. So, and this is the last point, developer can work on the fix without pressure after the revert is done, because there is another day, and another day we have another release. Okay, so let's look on this diagram again. Right, so we have the main branch, and we created a cut branch. We tried to build and test, analyze, we found regressions. Then we applied attribution by using the multisect. We have a blame commit. Now we are in a remediation step. We are reverting it and picking. That's it. No, wait. So what if we have merge conflicts, right? So this is the question, because there's many changes landed in the code base, and some other commits which landed later can be dependent on the blame commit, right? And for that we have this method, and it's called calculate revert path. What it does, it checks and finds all other commits which we also need to revert. So our main branch after the reverts will be in a clean and stable state. Yeah, so and this is what we are doing. We are reverting each of those commits, and then we wait for all of them being reverted, and then pick all 3 commits, as in this example, to the branch. So this is how the reverts and picks work for Lite. Shipping to 100%. So we have a package that we know that this package is in a good shape, it doesn't have any regressions inside, and we are ready to ship. This is how we ship. We basically ship in a gradual ship each and every time to 10%. We wait a bit, make sure that the servers are healthy, and increase the rollout to another 10% and until we reached 100%. The interesting part about the Lite servers is that they have the capability to run 2 versions in parallel within the same process. And if in this example we are, for example, shipping version number 2, then version number 1 will still be live and will keep serving existing old sessions, while version number 2 will start serving a new sessions. And this is important because if you remember, we said this is a stateful service, and it's important that we are not disconnecting any sessions and making user experience bad. And after some time, we will drop the version 1 and only version 2 will continue serving users. So orchestration. So what is this thing, the orchestration? It always starts on time. It never waits. It's always the release will start at 6 a.m. and each and every day. Just an example. This thing aware of the release flow. It stores the release data. For example, when each of the building blocks started running and on which phase we are, what failed, etc. If things go bad, and for example, we are not able to attribute correctly on remediation stack, then it will stop everything and it will call for help. It will not take any decisions to ship bad versions to production. It's configurable, it's subscribable. So just an example use case of is that developer may say, hey, like I want to be notified when my commit reached production, so they can subscribe to the release. It has a UI, and there is a permissions validations to make sure that not everyone can ship any version to production, and it has a lot of integrations with internal tools. And this is, I think, our last diagram, and this is pretty summarize all the release flow. So from the orchestration perspective, we start at 6 a.m. and we notify and can write in a group post saying, hey, the new release just started, so people can subscribe to this event if they want to. And if you have your commit as part of the of this release candidate, you'll also be notified that your commit is in about to be shipped. And then it starts running actual the release flow. So right, it's a run, it has a state machine, it knows how to proceed from each step to another step. It's actually the brain of this flow. And we start from the branch cut, and then we build, test, we run a canary analysis. If we don't have any regressions, we ship. And if you do have regressions, we go into the stabilization phase, which is running a multisect as part of our attribution, reverts and peaks, and we start again from building, testing, and canary and running an analysis to verify that the issue was actually fixed. Having no regressions, we ship. Once all the release is done, we are going to the finalize step, and we update our database entities saying that this specific release was completed, and again we can notify and sending emails and posting on the groups, etc. Cool. So few sentences about what is the release operator UI, what is used for, and we have such tool, and this is an internal tool, but maybe it's interesting to hear what kind of things we are surfacing on this tool. So we are surfacing the current release status, the changelog of the specific release candidate, the links to the canary and the analysis results and the current status. What are the blames we found? What are the reverts we found, including all the revert path and links to the commits? And we provide many logs, I would say, for easy debugging. And there is also options for manual operations. So if someone can pause the release, they can resume the release, they can go from one phase to another. And there is also an option to write hotfixes. And it's also very useful to go and see the historical data about each and every release. What things someone can be subscribed to, and also release keeps you updated via workplace, and code review tools. So for example, just an example, if you have reverted someone's commit, we will go and comment there and say, hey, your commit was reverted, and due to the following reasons, because we found regression X and it was spiking by this number of hits, etc. We will send emails, and we can update on the issue tracking tool. So there is some very urgent issues, we will create a new task and assign to the right developer, and more, right? And those are the release metrics we care about. And there is a many, but some of them, and I think this is very important. We will be in a takeaways, but this is really, really important to measure everything about the release process. So we are measuring time to completion of, and it can be of build, of tests, of how much time it took for the analysis to run of the canary, and how much time it took for the remediation to run, how the calculate path, all these kind of steps we are executing. We should be measured and understand where we're spending most of our time. All the manual actions, right? So we have today the automated release. We didn't have, I don't know, maybe 2 years ago, we didn't have this, and most of the things were done manually. So we need to measure and understand what are the manual actions release operator, for example, take. So we'll be able to say, okay, those are the important part, and those are the things we want to automate first. The noise, everything that creates false positive, from the detection, attribution. It's important to measure the noise and see and make sure it's always on 0. And if things go wrong, we should investigate. Storing the regressions, it's also important because because having and knowing what regressions were detected in the past helps us to build better regression detection analysis and validate those against the historical data. So this is very important. Commits, contributors, everything per release, like all this metadata and data about this release, and it's also important. For example, number of contributors, right, or number of commits. In the code base is growing, the teams are growing. It might be that we added a new package as a dependency, and suddenly we see so many commits. We should track those. Building block performance, reliability, release info reliability, and more. So there's many metrics you could measure, and it's important to measure those. And we will finish with takeaways for this presentation. Storing and measuring. So as mentioned before, historical data in measurement will help you improve over the time. Be mindful about the users and developers. Or provide early feedback to developers, explain why you reverted, and provide all necessary information to help them understand the reasoning. Don't create any noise. This is important. Anything that provides signal within a release process, such as attribution or detection, must not have any false positives. Otherwise, the experience won't be great. Right, and it's also kind of prevent you from automating the full release. Provide integrations. So if looking from as our CI/CD team, our customers will be developers, release operators. We want them to be notified. So we want to provide them ability to subscribe to specific events. Make it a happy path. And I think this is everything is important, but this is very important as well. Invest in CI and test to catch regressions earlier. So it will reduce any need to run the stabilization as part of the CD flow. Right? So if you have no regressions, it's always be a happy path. And this is really good for everyone. So thank you very much. It was really great to present here today. And that's it.
Thank you so much, Roman, for sharing the secret sauce behind fast and reliable deployments of the FB Lite. It's been very, very insightful. I'd like to remind everyone that they are able to ask their questions on the Discord channel. And while we're waiting, I have so many questions actually. So one of the questions would be, I mean, it's pretty clear that there is a quite significant overlap between what you've built and the Captain. So I wonder about the flexibility that your solution has compared to Captain. Like, for example, do you have a generic ability to define SLIs and SLOs?
So yeah, so this, can you hear me? Sorry.
Yes.
Yeah. So yeah. So we have pretty tailored solution for Facebook Lite, and it can span to additional solutions. But for example, from detecting regressions, we have spent some time on understanding what are the right thresholds, what is considered to be regression, what kind of regressions, and it will be different from one service to another service. It depends on number of users or number of sales or size of the fleet, etc. So yeah, it's a similar conceptually, I would say, and it's So maybe to answer your question.
I mean, that's exactly why the reason why I'm asking is because you mentioned that these thresholds are going to be different for different services. And that's why I wonder if they are configurable by others, or you have to provide this as a tailored solution. Because with Captain, the clients define their SLIs and SLOs. They are in charge of deciding what is meaningful for their service, what determines reliability or performance or whatever metrics they care about. Whereas if you provide the custom built solution, then you essentially have to either work with your customers, which is potentially maybe a little bit less scalable, or you have to make decisions for them, which is not ideal. So that's the reason. So do you define the metrics and thresholds, or the customer?
Yeah, it's a good question. I think in this case, so this is a really good question. So it started from a generic thresholds, and then we had to find the optimized one, because, for example, if we put some thresholds, that they might create noise, and because or misregressions, or if you put like very low thresholds, you will find too many regressions, but there will be a false positives. So here we need to come to the team and start looking what are the exact approaches we need to take, and how the servers behave, how the how the load on the servers looks like, how many sessions are created. So those kind of things and this kind of the analysis was done with the team to understand what are the exact thresholds we need to build and what kind of the analysis we need to build. And it will be tailored solution in this case. For example, just an example, since the FB Lite is a pretty big fleet, for example, we went to the other teams, we're having a lower number of servers. And we did found that some of the approaches work for them, but some of not. So because when we build an analysis, we say, hey, like we know that there is a big number of users on each and every server, so we can take some assumptions. But if there is only few number of users, or it's distributed differently, some of the techniques will not work. So it's so we work with the team. We can provide some generic thresholds or some generic solutions that they can configure those. But then it will, if you want to bring it's like to the very precise detection and attribution and remediations, then probably it needs to work more closer with the team.
Interesting. Throughout my career, I've noticed that the thing about the thresholds and knobs and that, like all types of configurability options that are static, is that they are always wrong, or at least they quickly get out of sync with the reality, just because the things change. Like, what was expected yesterday may not be necessarily expected today, because, for example, maybe we have more users because we have performed the rollout to a broader audience. And so basically some of the characteristics are going to change based on those things. And that's why, so recently I've read an awesome post from Netflix about their system called Telltale, where they try to basically use statistical analysis, machine learning, and a whole bunch of other techniques to automatically infer what an abnormal behavior is, and then essentially tune the knobs automatically based on that behavior, instead of requiring or relying on the customers. Although the customers are always they always have an option to override and set the hard thresholds if they want to. So I wonder if you have experimented with something like that.
Yeah. So first of all, we have alerting on the. So one of the very critical part of this release flow is basically the canary and running the analysis, because this is a very critical to detecting regression. So if it's not working, we just can release everything like bad builds to the production, right? Or if it's like working but really bad, and then we start just detecting wrong issues and everything. And it can happen because of the infra changes, or because someone changes how the analysis work. And this is important, for example, in our case, to provide the additional infra to play with the analysis. So basically we call it a shadowing. So we provide this basic that how the analysis is currently running. Anyone can improve the analysis, and then we will compare the results. And this is also important why we save the historical data about detected regressions, so we can always compare the new analysis, which is on a critical part of the release, with previous results. In addition, sometimes it might happen really bad issues when we lose logs, for example, or nothing is logged on a server side. So in these cases, we have alerts and to make sure that the system actually behaves on the infra side, and it's not saying like everything is right, but just because there is no logs to look. And so this is kind of additional alerting on the orchestration on the release part should exist to make sure that it's running reliably.
I see. That's interesting. And we're criminally out of time, but I cannot help asking, since it's such an awesome platform, and I would imagine a lot of people are actually asking for that, because I mean, what could be better than a calm, confident sleep at night where you don't have to worry about these things, you know, everything is just going to happen for you. So I wonder if you have any plans to generalize this as a generic service that you're going to provide for more products within the company.
Yes, we have talked with a few other teams, stateful teams that are using stateful services. It's like this is the challenging and it's interesting part. Yes, we have talked, and we actually already, like, for example, the Multisect. So we can generalize and use it as a first thing, like as a black box. You just provide range of commits, and then and it returns you a blame D, for example, and then like the remediation black box and some kind of black boxes, and start applying, and then later see if we can build the whole release process, like bring the teams to the common release process. We do find some changes between how the team approaches some release, and like for us it's like, looks, this is the right release flow, but other teams thinks differently. So we first need to agree on the common and the generic part of things that everyone agrees on, and then reuse them, and later see how we can come to the unified platform and what's the right platform to be. We are thinking not only about services, but also about the mobile platform. So like Android, iOS, how those looks like, and this is also interesting. So they don't have canary, but they have this kind of gradual rollout. But it in some sense the gradual rollout exists for the detection part, and this is how you basically use the gradual rollout and call it a detection. And so this is really interesting. We are thinking about this a lot, and we are trying new things in this area. Yeah.
Well, thank you so much for staying awake for so long for the event. Really appreciate it. I hate that we don't have more time for the questions, but yeah, feel free to, like, everyone who hasn't had the chance to ask their questions, please feel free to head to the Discord channel and ask Roman about the awesome infrastructure that he's building at Facebook. Thank you so much again, and have a wonderful night.
Thank you very much. Thank you.